Now let's look into some of the use cases of Terraform. So HashiCorp Terraform is an infrastructure as code tool, that's a IAC tool that lets you define infrastructure resources in human readable configuration files that you can version, reuse, and share. So you can then use a consistent workflow to safely and efficiently provision and manage your infrastructure throughout its life cycle. So this slide describes popular Terraform use cases and provides related resources that you can use to create Terraform configurations and workflows. We will begin with the most important and widely helpful use case is multi-cloud deployment. So in multi-cloud deployment, provisioning infrastructure across multiple clouds basically increases fault tolerance, allowing for more graceful recovery from cloud provider outages. However, multi-cloud deployment is not that easy. It's very complex. So multi-cloud deployment add complexity because each provider has its own interfaces, own tools, and own workflows. GCP, their own interface. If you see the Google Cloud Platform, their interface is different. Amazon Web Services, their interface is different, and IBM is different, and Azure is different. I have worked on, by and large, all of the cloud platforms that I have just mentioned. Each of their interface is different, tools are different, and workflows are different. However, fundamentally the services they provide are same, but the names of the services changes, and with a slight complexity attached to that. So Terraform lets you use the same workflow to manage multiple providers and handle cross cloud dependencies. So this actually simplifies management and orchestration for large scale multi cloud infrastructures. And the second use case using Terraform is application infrastructure deployment, scaling, and monitoring tools. You can use Terraform to efficiently deploy, release, scale, and monitor infrastructure for multi-tier applications. So if you see, you require for any microservices or any big application. If it is a microservices application, it consists of lot of microservices, and if you want to run it separately in instances, then you have to deploy, release, and monitor a lot of infrastructure, a lot of instances. In that case, this one, our Terraform would be come to our rescue. So entire application architecture lets you scale application components independently and provides a separation of concerns. An application cloud consists of a pool of web servers that use a database tier with additional tiers for API servers, caching servers, and routing meshes. So Terraform allows you to manage the resources in each tier together and automatically handles dependencies between tiers. Let's take one example to get the clear picture of what I'm talking about. Uh, for example, Terraform will deploy a database tier before provisioning the web servers that depend on it. So this is the best example to reflect what I was talking thus far. Then we have the third use case is PaaS application setup. Platform as a service. Basically, PaaS is platform as a service. So this is the best use case for the for using Terraform. So setting up a PaaS, a platform as a service. So PaaS vendors like Heroku, of course, Heroku allows you to create web applications and attach add-ons such as databases or email providers. So Heroku can elastically scale the number of dynos or workers, but most non-trivial applications need many add-ons and external services. So in this case, in this kind of complex situations, you can use Terraform to codify the setup required for a Heroku application, configure a DN, simple to set a CNAME, and set up a Cloudflare as a content delivery network for the app. D and a content delivery network for the app. So Terraform can quickly and consistently do all of this without a web interface. And the best and the fourth use case is Kubernetes. Kubernetes, as we all know, it's an open source orchestration container orchestration tool in specific. So Kubernetes is a open source workload scheduler for containerized applications. So Terraform lets you both deploy a Kubernetes cluster and manage its resources. What are the resources of Kubernetes? If anybody knows, just repeat with me. It's one is pods and deployments and services. So for each of thing, you have to write a definition file, the Kubernetes definition file to create and manage these resources in the Kubernetes cluster, such as pods, deployments, and services. So Terraform makes it much simpler because I have worked on Kubernetes without Terraform and Kubernetes with Terraform. With Terraform, it's a cakewalk. It's simply a cakewalk. So you can also use the Kubernetes operator for Terraform to manage cloud and on-premise infrastructure through a Kubernetes custom resource definition, CRD, custom resource definition file, and Terraform cloud. Then the last but not least use case is software demos. So you can use Terraform to create provision. You can use Terraform to create provision and bootstrap a demo on various cloud providers. This lets end users easily try the software on their own infrastructure and even enables them to adjust parameters like cluster size to more rigorously test tools at any scale. So then we'll close up, we'll wrap up the use cases with one more. So in software demos, there is a concept called parallel environments. You may have a staging. That's what in software demos, basically we'll have a lot of deployment stages. So one in production, then development, then you will have a staging area, then testing area. So there are different stages where we deploy our application. So that's why the parallel environments, you may have staging or QA, that's quality assurance environments, that you use to test new applications before releasing them in production. So as the production environment grows larger and more complex, it can be increasingly difficult to maintain an up-to-date environment for each stage of the development process. So Terraform, what does Terraform do? How will Terraform help us? Terraform lets you rapidly spin up and decommission infrastructure for development, test, QA, and production. Using Terraform to create disposable environments as needed is more cost efficient than managing each one independently. So, in a nutshell, if you put it in a single in a one two lines of statement, so Terraform will help you from development stage till production stage in setting up the servers and configure in setting up the servers with rapidly. Okay, so that's how it helps. So it's this Terraform, using Terraform to create disposable environments as needed is more cost efficient than maintaining each one independently.